All right, next one. I have 2 more left. Next one, more commonly missed than any because of the negative. Okay? This is definitely what we want to solve for because it's the only one without a coefficient. So that's definitely by far the easiest one. You just got to watch the negative there. Okay? So if I'm going to get that y by itself, I'm going to minus the 3x. And then I have the negative y, still negative, and then either negative 3x minus 5 or minus 5 minus 3x. Order does not matter. And then we're ready to sub. Oh, no, we're not. Oh, no, we're not. Our y's still negative. Sorry. Divide, that's what I was saying made it harder. Divide by that negative 1. And then my negative 3 over negative 1 becomes positive 3x. And my negative 5 over negative 1 becomes positive 5. The signs change. Now we're ready. Y equals. Y equals. So it's got to go in for y. So I'm going to make my substitution. So 5x plus 2. Y is coming out of the game. 3x plus 5 goes in the game. Equals 21. So we distribute. Positive 2 times positive 3 is positive 6x. Positive 2 times positive 5 is positive 10. Equals 21. Collect our like terms. 5 and 6 is 11x. Plus 10 equals 21. Subtract the 10, and 11x equals 11. And then divide by 11. And x equals 1. And then back here, best place to go. Fastest, easiest, quickest, doable in your head possibly. Three times 1 plus 5. 3 plus 5. 3 times 1 is 3. And 3 plus 5 is 8. Gosh, I cannot finish this. Okay, question there. Okay, my last example does something a little bit different. I'm going to start it the same way, and then something's going to happen. The best variable to solve for is this x, because it's the only one without a coefficient. So that's what I'm going to do. So I'm going to subtract then the 3y. So I'm going to have x equals negative 3y plus 8, or 8 minus 3y, it doesn't matter. If you don't like that negative first, make it 8 minus 3y. We're ready to sub. It's going to go in for x. And by the way, you don't have to draw all these little circles unless you want to. If that helps you, do that. You don't have to. Okay, so this is going in x equals to the other equation for x. So I'm ready to sub. 2. X is out of the game. Negative 3y plus 8 is in the game. Equals 14 minus 6y. And then I distribute. I solve. 2 times negative 3, negative 6y. 2 times 8 is 16, equals 14 minus 6y. I'm solving, which means I need my variable to one side. So I'm going to add from here. I like them on the left side, so I'm going to add the 6y to get rid of it. But when I do that, it cancels out on the left also. We wanted it canceling on the right, which it did, but it also canceled on the left. And I get this statement that says 16 equals 14. Is that true or false?
False.
False. 16 equals 16. 16 doesn't equal 14. Okay? When this happens, when your variables drop out, no variables left, and you get this statement that is not true, then that's your answer, no solution. Which means, had I done this question using the graphing method, what would have happened? Yes?
It would have gone parallel.
It would have gone parallel. Awesome. Pull it together. Very good. Okay? So this is a question where if I had graphed it, my lines would be parallel. Academically. Algebraically, this is what it looks like when they're parallel lines. The variables are gone, and you get a false statement. Okay? Seem complicated?
There.
A little bit. Until you do it, sit down and try it.